It's a pleasure to be here, pleasure to do this presentation. Like many of you probably, when asked to do a presentation on something that was important to me, I couldn't really think of much that was appropriate to do a whole slideshow on for a class. But after sitting in genetics class, I was able to find something that was very interesting to me, something that actually became something that I'm passionate about. So today I ask you, could a potato save a life? It's a little bit of a ridiculous question, I know, but science is on the cusp of making that possible. Science is very close to making it possible so all children can be vaccinated by simply eating a potato or a banana or some other kind of genetically modified food. This is important. It's important because many children go unvaccinated. Many children die of preventable diseases, and there's really no reason for that. So we need to make these vaccines more accessible for these children so they don't have to suffer from these diseases that are completely preventable. All of my information today is taken from Brother Ryrie and references that he's given me. Brother Ryrie is a professor here on campus. He's got his PhD in molecular genetics. He's worked for a company called Quigen, which is a company in the field of microbiology. And he's also co-authored 3 books on genetics, and so he knows a lot about this stuff, and he was able to help me find some references and help me out on this presentation. So today, I'm going to present to you edible vaccines and how edible vaccines can benefit humanity on the whole. So I'm going to go ahead and preview my 3 points that I'll be going through. I'm going to show you why they're important, the crisis that we face with our children, and how many children go unvaccinated each year, how many die, and those things, just so you get an idea of why this is so important. I'm also going to go over how they're made. I'm going to go over how they're made so that I can kind of eliminate some of that fear that people have about genetically modified plants, hopefully. And I'd also like to go over their current status and go over why we aren't seeing these things more readily available. Go ahead. Great. So why? Why do we need these things? Why is it important? Don't we have vaccines already? Yes, we obviously have vaccines already, but we see But we see children dying from cholera each year in developing countries. Cholera is a completely preventable disease. There's a vaccine for it, and yet it's a leading cause of death in many developing countries. For me, I think that's inexcusable. I think that we need to make these vaccines available so these children aren't dying each year. We see 20% of infants going unvaccinated each year. Again, inexcusable, especially when we have them. That equates to 2 million deaths per year from preventable diseases. We see 2 million infants dying each year from preventable diseases. And I believe that if a pandemic like that were to happen in our country, we'd be more excited about this. We would be more supportive of these edible vaccines because they'd be more accessible. These would take less than ½ cent to produce. It's simply growing a vegetable or a fruit. Less than ½ cent to produce. There's no needles involved, and so you don't run the risk of spreading diseases like HIV and AIDS, which is a big problem in Africa. And they can be grown locally, and so you don't need doctors and nurses to visit. You don't need to pay them. It doesn't cost to bring somebody in like that to administer these vaccines. The locals can simply be shown how to grow these and simply eat them. And they can vaccinate their children as well as themselves. Okay. So quickly, I'd like to go over how they work. This is not an all-inclusive thing. It's very basic, very simple, just to help you understand how vaccines in general work. So classically, we've had vaccines that have the entire pathogen, which is either dead or so weak that it's probably not going to come alive. But what doctors always run the risk of is that disease that they're vaccinated against actually coming alive and infecting the person. And so we have this vaccine with the pathogen or the disease-causing agent in it, which is either dead or very weak. We introduce it to the body. We see how the body reacts. It releases antigens to fight against it. And so the body is learning how to fight against this pathogen. And in this case, what's great about that is the pathogen is either dead or very weak, and so it doesn't pose much of a risk to the person being vaccinated, and your body can learn how to fight against that. It's kind of like practice for when it's introduced to the real pathogen. And then the body already has those antibodies to fight against the real pathogen. And so the person doesn't get sick. It kind of boosts the person's immune system. And so we see why vaccines are so important. Go ahead. Great. So I'd like to show you how they introduce that vaccine into the potato here. So we have a vaccine. Everything has DNA. The vaccine itself has DNA. We take that DNA from the vaccine, so it only produces a simple protein from the vaccine. So now we don't run the risk of the person actually being infected by what we're trying to vaccinate against, because we're only using a simple protein, you could say a piece of that, to vaccinate against them. So the body still recognizes that little piece, that little protein, as the pathogen, and still builds up those antibodies, so when they're faced with the real thing, their body can fight against it. And so we introduce that DNA that will produce that protein into what's called a plasmid. A plasmid is simply a vector that is really easily accessible for bacteria, which is what we have in this dish here, to adopt that DNA. And so you introduce the DNA, the bacteria actually adopts that DNA into its own DNA. Then you introduce potato leaves, or whatever other vegetable. The potato is the most common right now. You introduce those potato leaves, the bacteria actually introduces that DNA into the potato leaves, so the DNA adopts that DNA as its own. You're actually able to grow whole potato plants from those leaf segments. You collect the seeds, then you can use the seeds to grow those vaccinated, or those edible vaccines, the potato with the vaccine in it. Go ahead. So it's really important that we're able to do this. It's, you know, like we've seen those 2 million children dying each year, 20% of infants going unvaccinated, children dying from cholera, something that's completely preventable, really kind of inexcusable. So I'd like to go over why we aren't seeing these everywhere. Can you go ahead, please? So in the beginning they ran into problems with cooking. Obviously nobody eats a raw potato, you have to cook the potato. So in the beginning, when you cook the potato, it would actually cook a lot of that vaccine out. They were actually able to clear that hurdle, you could say, and when you cook it now, it only eliminates half the vaccine. So yeah, you administer a higher dose, or you give them more potatoes to eat, but you're still getting vaccinated. So you're able to cook those potatoes and still be able to get vaccinated. And it doesn't affect the taste as well. Another problem you have is low yield. Anytime you start messing with genetics, you start introducing new proteins to organisms, you run the risk of it spontaneously aborting in the process, you run the risk of it simply dying because of that foreign protein. But that's another hurdle that they've been able to clear, and they're able to actually have pretty good yields for these edible vaccines. The biggest problem that we face today with edible vaccines is funds for research. Anytime you mention GMOs, it's kind of a red flag issue. It's a hot button issue. Like many of you that are watching this today, by simply hearing the word GMO, maybe you had some kind of emotional reaction to that. But GMOs are safe. There's been no clinical trials that have found that they're bad, that they do any harm to you. And they can actually do a lot of good in the world. And this is an example. And so I would encourage you to encourage funding for these genetically modified plants so that they can use them for such good things like vaccines, and they can help these children gain access to these vaccines. This has been proven to work in mice. It's been proven to work in other animals as well, but it was originally proven to work in mice, and actually, can you put it again? It's worked in people as well. So we know this works. This is a fact. It works. Many countries are so desperate for vaccines and so desperate to help their people out that they're willing to be guinea pigs, if you will, for these genetically modified plants. And these are actually vaccinating, they're actually working as they're designed to do. And so we see that these vaccinations work. We see that they're important. Can you go to the next slide? We see that we as the world need them. We need to protect the children by giving them access to these vaccines. So by understanding why these vaccines need to be accessible to all children, by understanding how they are made and how they work, and by understanding their current status, where they're at now, and why we don't see them on a broader scale, you guys can feel more comfortable in supporting funding for these vaccinations. I would encourage you all to support funding for these vaccinations. I would encourage you all to find a way to support this cause. Thank you.